Now, today is separation techniques. We have watched many videos, all right, so that at least it gives you a better idea. Can I check with everyone? Have you all learned this topic already? Can you type in the chat yes or no? Have you learned this topic in school? Yes or no? Everybody type into the chat. Have you learned this topic in school? Yes or no? All right. Oh, Zixuan has not. Thank you. Thank you. Kiran, you have. Harvard, you have. Thank you for responding. The rest, have you learned this topic? Okay, doesn't matter. I hope just now the quick videos, if it's too fast, you can watch the videos again. All the links are shared with you. All right, let's start then. Now, first of all, you all must know, in set 3, I told you before, in set 3, you're going to choose subject called physics. Some of you will prefer to take physics, some of you will prefer to take chemistry, but anyway, all of you will take chemistry. All right, chemistry is compulsory. You either choose between physics and biology. All right, some will take physics, some will take biology. Okay, now physics will give you the word called physical method. Okay, physical methods. Sure, Kiran. Yes, go ahead. All right, chemistry comes from the word chemical methods. If your internet speed is laggy and you want to leave the room, go ahead and leave. I will re-admit you later. All right. So I'm trying to teach you how to remember the word physical methods and chemical methods. Methods can also mean means. So physical means or chemical means. All right. So chemical methods means new substance form. Something new is formed, then it's called chemical methods. Okay. Now, when we talk about mixture, mixtures can be separated using physical methods. So what physical methods are we talking about? So will be all these things. All these are physical methods. All right. So all the separation techniques are all called physical methods because let's say you separate, for example, oil and water. After you separated oil and water, you can choose to put them back again. It is still oil, it's still water. It doesn't form anything new. Or if you separate, for example, sand and sugar. After you have separated sand and sugar, you can still choose to put them together. Sand is still sand, sugar is still sugar. Nothing new is formed. Hang on, let me admit Kiran. Okay. Right. So all the separation techniques are called physical methods. Okay. So physical methods means no new substance is formed. That is the meaning of physical methods. All right. So separation techniques are all physical methods. Is everybody clear? All right. Now these are the set 1, set 2 syllables. So you need to know all these, which I showed you the video just now. Magnetic attraction, filtration, evaporation. Distillation got 2 types. Distillation got simple distillation, got fractional distillation. And then you have chromatography. All right. Then you need to have some examples of how all these are used in everyday life and how all these are used in the industries. Industries is like, companies or factories. Then you need to have some idea of Singapore water treatment. In Singapore, our water treatment, we use reverse osmosis or seawater. Either we use seawater or we use treated used water. Okay, and we recycle the water. That's how we get new water. Okay, now we will start. Now this is a big picture that I spent a lot of time creating this. So if you look at all the V, click on the V to watch video. Rishi, you're right. Reverse osmosis takes a lot of energy. All right. Reverse osmosis uses a membrane and it's like forcing the water molecules to go through the membrane, and then viruses, bacteria will be trapped and cannot go through the membrane. All right. So reverse osmosis uses a lot of energy, but no choice. All right. So these are all the separation techniques. 1, 2, 3, 4, 5, 6, 7. These are all the 7 separation techniques. All right. Reverse osmosis is also another separation technique. All right. Now, click on V to watch video. So when you get the PowerPoint slides, you can click on all these V. You click, it will open up the video. You click, it will open up video. I have shown you all the videos, but if you want to watch them again to refresh your mind, you go ahead and watch the videos. There's one more video which I have not shown you just now. It's called crystallization. All right. So let me give you a brief outline of what's happening now. Filtration is solid mixed with liquid. All right, and the solid cannot dissolve in the liquid. So it's called insoluble solid and liquid mixture. Then you use filtration. So for example, sand and water. Sand is an insoluble solid. Sand cannot dissolve in liquid water. So if you want to separate sand and water, very easy. Just use filtration, not filtration, it's filtration. There's no E, there's no E. Then you use a filter funnel. Then your sand will be left on the filter paper. Your water will pass through the filter paper. Water will be here. So here will be water, here will be sand. All right. So let me write for you, maybe in blue. So this will be the sand. All right. This will be the water. So that's how you separate sand from water. So now you need to learn two words. All right. Residue and filtrate. Residue is whatever is left on the filter paper. Filtrate is whatever that passes through the filter paper. Right? So sand is the residue. Water is the filtrate. Okay, so take note of filtrate. Okay, we have the word filter, which has a letter E. But filtration got no E. And then please don't spell filtrate wrong. Right? It should be filtrate. There's no E. Okay, no E. Right, filtrate. Okay, now we go to the second method, evaporation to dryness. Okay, then what is the difference? Now, solid mixed with liquid, here also solid mixed with liquid. Then the difference is here the solid cannot dissolve in a liquid, but here the solid can dissolve in a liquid. All right. So for example, salt and water. Salt can dissolve in water. Sand cannot dissolve in water. So if you want to separate salt and water, you can evaporate all the water to dryness. You can evaporate all the water away, say bye-bye to all the water. All right. So, but the problem with this method is the liquid will evaporate and go into the air. Then what you're left is only the solid. Okay. So only solid is retained. Only solid will stay with you. Liquid will go up to the air. You cannot catch it anymore. So for example, here you have salt plus water. Water will evaporate off, leaving behind salt. Okay. So I've shown you the video just now. So this is salt, the white color salt on the evaporating dish, and this is water that will evaporate into the air. So again, you can have, we call it residue that is left on the evaporating dish. So we use an evaporating dish when you want to use this method, evaporation to dryness. All right. Now take note that in some cases, you cannot use this method, evaporation to dryness. I give you one example. Copper 2 sulfate salt. There are many salts in the world, copper 2 sulfate. If it's sodium chloride, your table salt, sodium chloride dissolved in water, you can use this method, right? But if it's copper 2 sulfate, you cannot use this method. Instead, you will need to use crystallization. You can watch a video. Because if you use this method, my poor copper 2 sulfate will lose the water of crystallization. All right. Now, blue copper 2 sulfate is a beautiful blue crystal. If it loses the water of crystallization, it will become a very ugly white powder. Okay. So another reason why we use crystallization is because some salt will decompose when you heat it up. All right. So when you heat it up, some salt will decompose and make something new. And I don't want to make something new. I want the original chemical. So if the salt can decompose means break down and make something new. If that salt can decompose when you heat up, then cannot use evaporation to dryness, then you use crystallization. Okay, now next, simple distillation and fractional distillation. You need two words. You cannot just write distillation. Now, what is the difference between these two distillation? Now, this one is to separate S plus L, solid plus liquid, and the solid can dissolve in a liquid. Here is L plus L. Two liquids mix together very well. Mixable means can mix very well, right? So for example, ethanol and water. Ethanol is a liquid, water is a liquid. So L and L mix together. When you want to separate the liquids, you use fractional distillation when you want to separate liquid. When you want to separate solid from liquid, salt is a solid, water is a liquid. So S plus L, then you use simple distillation, right? So let me write it for you. So here is S plus L. All right, so this one is L plus L. Okay, so S means solid, L means liquid. Right? So, and then fractional distillation is you have an extra thing. This is the extra thing. Okay. Right, then paper chromatography is when you have two liquids mixed together, but usually it's in small amount. All right, so whatever can dissolve faster will be on top. So this one dissolves better in the solvent. Whatever material can dissolve better, it will go all the way up. Okay, we will take a look at some examples. So if you want to separate ink, or you want to separate dyes, colored dyes, or you want to separate drugs, you use paper chromatography. All right, so this one, this spot, this chemical, that means it is on top. That means it is more soluble in the solvent. This one is at the bottom, means it's less soluble in the solvent. If you are more soluble in the solvent, you will go faster. All right, magnetic attraction. So for example, iron and sand. So let me write that for you. So this one is iron. This one is, the white one is sand. So iron will be attracted to magnet. Okay, either iron or steel. Steel also attracted. So either iron or steel. Okay. So next, separating funnel, oil and water, they are immiscible. Mixable means can mix very well. You only see one layer. Immiscible means cannot mix well. All right, so for example, oil and water. So you have a layer of oil on top, you have a layer of water below. That's how you separate them. And then the one with lower density will float. All right, then for chromatography, if it has higher solubility in the solvent, it will be higher spot. Then for this one, the liquid with the lower boiling point will boil first. So ethanol and water, ethanol has a lower boiling point than water. Ethanol will come out first. Right, after all the ethanol comes out already, then water will come out. But that's how you separate ethanol and water. So lower boiling point will come out first, will be distilled first. Right? Okay, then whereas here, anything that's more soluble in a solvent, it will travel higher. Right, then here, any liquid that has lower density will float, will be the top layer. Okay, any questions so far? Right, then we move on. Now, these are elaboration. Distillation, there are two processes, boiling and condensation. Okay, anyway, you look at, okay. See the bulb of the thermometer is next to the side arm. Bulb of the thermometer is next to the side arm. So please don't go and draw a thermometer here or draw a thermometer on top. Okay. Now condenser, do you see there are two layers? All right. So water go in from the bottom and it goes this way and it go out from here. Okay. So water goes in and then come out from here. Okay. So let me highlight the water for you. Then you will hopefully understand this is the water. But not the center layer. Center layer is for the gas. All right. Now I think I better don't highlight so that you can see better lah. Okay. The gas will be go through the center. So the hot gas, after the liquid evaporate, you have the hot water vapor. Hot water vapor will come here. All right. So all the gases will go through the center tube, not the outside layer. Outside layer is where the water goes in and then water comes out. Okay, so water must go in from the bottom of the condenser so that the entire condenser can be filled with water. So that you have increased ESA. Remember ESA, exposed surface area, so that condensation of the gas, the water vapor, can condense faster. Right, so water in from the bottom. This is the how you answer. If I ask you, how come, why not water in from here? Why must it be water in from the bottom? So this is how you answer. All right, inside, I can draw some boiling chips. So let me draw some boiling chips.